In this video, we will focus on economic production quantity model with imperfect quality items. First of all, we will see a brief introduction of the economic production quantity. We will call APQ. The APQ is different than the economic order quantity model because it assumes that we are producing the inventory at the factory, and therefore we will have to account for the inventory holding cost as we produce. First of all, we will identify which equation represent the APQ model. On the left side of the Excel, you can find all the variables that are used to build this equation. The APQ equation is defined as the square root of 2 times the yearly demand times the ordering cost per order, everything divided by the holding cost per unit per year times 1 minus the daily demand divided by the production rate. As you should have learned during the IMT digital course, this equation determines the optimal production quantity. However, manufacturers' production process quality is often not perfect and hence produce imperfect quality items. Moreover, also during the inspection process could occur evaluation errors in finding defective items. Therefore, in this video, we will focus on the economic production quantity model that incorporates both imperfect production quality and two-way imperfect inspection. So those are type 1 and type 2. This framework will give us an overview of the whole inventory flow of the imperfect quality and imperfect inspection inventory system. And therefore, it will help us to understand the two types of error that we named before. First of all, let's take a look at all the variables that are involved in this model. Y represents the lot size. P is the proportion of defective items, where P assumes a value between 0 and 1 and follows a known probability density function. 1 minus P is the proportion of non-defective items. Q1 is the proportion of items screened as defective, however are non-defective items. Q2 is the proportion of items not screened as defects, however they are defective items. R is the proportion of rework items, where R assumes a value between 0 and 1 and also follows a known probability density function. 1 minus R is the proportion of salvage items. So let's assume the manufacturer produces a lot size Y. Since the production process is not perfect, the lot Y contains defective items and non-defective items. Simultaneously, the entire lot Y will be subjected to inspection, where the items will be sorted between screened items, thus defective items, and serviceable items, thus non-defective items. However, since the inspection process is also not perfect, among the serviceable items we will find also unscreened defective items, thus generating type 2 error. And among the screened items we will find screened non-defective items, thus generating type 1 error. Those customers who bought defect products will detect quality problems and return them to quality dissatisfaction. In handling those screened and returned items, the manufacturer can use two disposition alternatives: rework and salvage. The reworked items are used to satisfy demand like serviceable items, whereas the salvage items are assumed to be salvaged as a single batch at a discounted price at the end of each production and inspection cycle. To calculate the optimal production quantity Y with this new model, it is therefore necessary to add in the original formula the variables previously depicted. In the next part of the video, we will show you how to apply this formula to a practical example.
In this part of the video, a practical example will be given using our new model. First, let's have a look at the data that we have here. As you can see, the known variables from the basic EPQ model are marked in yellow. So let's have a quick look to the new variables. Rework rate is how much time takes a unit to be reworked. These are the costs per unit. Defective proportion is the share of items with defects from the produced amount. Type 1 and Type 2 inspection errors are the proportions of Type 1 and Type 2 error in the produced items. Rework proportion is a quota of items that need rework from the produced amount. More detailed information about these variables will be given at the end of this video. Now, let's find out the optimal production quantity. To be able to achieve this, we have to use this formula here. Don't worry, it looks more complicated to use than it really is. However, to avoid mistakes, we will first separate the equation in 4 subquadrants, calculate them independently, and then all together to find the final solution. As you can see, we have auxiliary variables in our main equation, namely alpha, beta, and sigma. We begin by calculating sigma. We only have to use the values that we already have and write them based on the equations on the side. As you can see, we have the value of p plus open parentheses 1 minus the value of p closing parentheses times the value of q1. We do the same for the next two variables and we get these results. Now we move on to calculate the subquadrants of our main equation. Again, we only have to replace the values that we already have in the equations that we have here. For quadrant 1, we have the value found in q1.1 divided by the value of alpha. We do the same for the next quadrants, and finally we calculate our main equation. We use the function square root and put the value of quadrant 1 divided by, open parentheses, the value of quadrant 2 plus quadrant 3 plus quadrant 4, closing parentheses, which give us this final result, which we will copy as our value for an optimal production quantity. This was everything. Thank you for your attention.